B.
B. Okay. Why wasn't it one of the other ones? More generic, more general. Is that true, Hector? Who's Hector? Is that true? Is it more general? Yeah. So we said it was B because it's more specific to the parent, but why is it more specific? What is it doing? So it's taking the parent stuff and then it's doing what?
It can't be more generic. Inheriting something, you know.
Yeah, so whatever the parent has, it's got, and then it's going to add some other stuff to it, right? Okay. And you see things like all, always, you know, really be cautious of that. Of course not. You can, but it's not required, right? Okay, this one's fairly obvious, right? You know, it's not, this might be the result of using inheritance, right? But that's not, it's not the intention, right? You want to make it you want to make it clear, but the point is you want to reuse code, add new methods to previously defined class, and redefine specialized existing methods. What does a child inherit from its parent? Andrew, what was the answer you guys came up with first? What was your answer that you put on your first quiz?
All of them.
You put all of them, okay?
Yeah.
Why? Why is that true?
Well, everything in there is inherited. Yeah. I go to your diagram, like the parent was inside and then the child was outside.
Yeah.
So if it's inside of it, everything inside it is inside of it. That's how I like worked my logic through, and then I was like, okay, yeah, it's got to be all of the things inside of it.
Yeah. Logic as tenuous as that was.
Yeah.
Okay.
I can speak longer if you want me to keep going.
I think you probably can.
Okay.
You probably have, you know, the beginning part of your day, right? So we'll give you a rest. Okay. Okay. So yes. So what happens is that when we say inherit, what does that mean? It means that that stuff is there. Can we access all that stuff? No, we can't. We can't necessarily access those private variables directly. We can't access the private methods because those are reserved only to things of type animal. Yes?
I'm sorry.
Yeah.
So, if they're there, well, they are there, right?
Yep.
The private variables and
Yep,
private
they're
methods.
inherited.
But you can't call them, right?
Directly.
Directly.
Right, because more than likely what's going to happen is if you have a private variable in here like an x or something like that, you're going to have a get x method. You're going to have a get y method. If those things did not exist inside a var, you would not be able to set x. You would not be able to set y. Even though they're private variables, you can access them. There's locations they can be set, they can be changed, etc.
But you wouldn't be able to set them with a pair.
No, you would, of course. Yes, absolutely. Yeah, as long as the animal class had set and get methods for the for x and y.
You couldn't say x equals, you have to say set.
Yeah, you can't say x equals. However, you can say set x.
Oh, okay.
So there has to be a space in the var that represents that x variable. Yeah, Clay.
Okay.
So this question is not asking what it can access, it's just asking what it can inherit.
Exactly.
Because to
So
me,
it's
those
more-
are the
it's
same
more-
thing.
It's not.
So
It's not the same thing, right? It's not the same.
yeah, that's
When we
what
say
I thought.
inherit, that's a more general term. What we're saying is that within the var, there's going to be these things, even these private methods. Because what could happen is that you might call a public method from a parent, but then that parent then calls its own private method, and so you might not be able to access that method directly. You're still going to be able to use that method. Okay.
That's where it's
Okay. So don't get confused about the point that it's inheritance. It's not being able to access it. Those are two different things.
So the purpose of the parent having a private method is so whatever's being done with whatever.
Yeah, it
Either
doesn't.
it's kept private and then the people who inherit from the parent can't change that particular method.
Exactly. They can't access it directly. They might do it indirectly because there might be a public method that calls that private method.
Right.
And that's usually what happens.
Okay.
You don't usually have a private method that's, it's on its own. It's usually nested within a side public method. And so you can access that thing indirectly.
Like a private method that does a bunch of calculating and a public
Yeah,
method calls
yeah,
on
exactly.
that.
Yeah, exactly. It gives you the interface to that particular calculation rather than the actual calculation itself. Right, exactly.
Yeah,
Okay, so that's the difference. Can it access all those things? No. Does it inherit them? Yes. All right, that's what this question's getting at. All right. This one's fairly obvious, right? Super. So, were there any questions about that one? Okay. Visibility. Now, this is what we're talking about when we're talking about things that they can access directly, right? That's what we're talking about when we say visibility. So Sean, what did you answer the first time you did this? When you did the first quiz, what was your answer?
Protected.
Protected, okay. Did anybody else have anything besides protected at the first quiz? Couple people? Okay. What did you have? Public?
D.
D.
So I
It doesn't
thought I could
matter,
see
okay.
everything, yeah.
Yeah, well, obviously, because there's going to be restrictions on all the variables, okay? So you have, some are going to be private, some are going to be public, just depends. In general, the variables will be private. Now, technically, C could be an answer, but that's not the intention of the public access server, right? That's so that everybody can see. It's not restricted to just children. And so, just make sure that you understand the difference. All right, let's go on from there. Okay. The best way to look at this one is first of all, you want to draw a picture, and we can do that real quick. I think most of you probably did. So what do we have? So we have this blue thing, and then we have a Smurf, right? And then there's also this interface which we're calling Singer, right? I don't know, do Smurfs thing? Okay.
Yeah.
Oh. Okay, all right. I missed that. All right, so the point is that if you look, okay, so you have this Smurf thing. Within the Smurf thing, you have a blue thing, right? And next to it, you have a Singer, which is just the methods that are associated with the Singer class, right? Or interface. Is a Smurf a Smurf?
Yep.
Yes, it is. And because this is not abstract, we can go ahead and create a Smurf object, right? Is a blue thing a Smurf? It is not, right? Blue things don't know anything about Smurfs, right? It's contained within the Smurf, but the blue thing by itself doesn't know anything about it. Is a Smurf a Singer? Is a Smurf a blue thing? Right? So that's what the way you want to approach those kind of questions. What's the static? Well, now we'll worry about that here in a second. So these are I hope are fairly straightforward. So in this case, we're asking about the giz, right? So the giz is just a gizmo. If it doesn't have that method associated with it, where's it going to look for it? It's going to look for the parent, right? And it's going to go up the inheritance chain until it gets the object. And if it doesn't find it, then it doesn't have it, right? Then that's going to be in here. And so that's why it does what? In this case, it does beware of spinning, right? So that'd be D. Next one, it's exactly the same thing, except for thing has its own method. So it's just stay back, right? Now this is where it might have gotten a little bit confusing, but let's go ahead and let's just look at this real quick. What's going on here is that whole static versus dynamic type, right? What is the static type of M? Monitor, right? That's the label, that's the handle that we're going to use. Whatever we grab has to represent a monitor. What is its dynamic type? A widget, right? So the picture we want to have in our minds is this. So we have this widget, right? Did I forget, does a widget directly inherit from? I think it does. It gives, wait a minute, monitor, right? So when we're seeing something like this, we have a widget object. And what we're doing when we say this is we're just grabbing the monitor handle of that thing inside. Right? And so the dynamic type is going to be widget, but we're holding it by its monitor handle. So the actual object that we have a hold of is a widget. So all the methods that are associated with widget are the ones that we're going to execute. Because this is a widget object, even though we're holding onto it with a monitor handle. And so that's where you have to be careful about these things, okay? You got to think about the object that it's holding onto, not necessarily the part that it's actually holding onto at that moment. And so that's why, in this case, we're going to do mReport. mReport, if I remember. So we go up to our widget, right? So it's beware of spinning, right? Okay, make sure you're not confused about that. That's dynamic versus static types.
So is static type the same as declared type?
Yes, exactly. Yep, same thing. Yep.
So your declared type basically says what methods you can access. Let's say,
Declared type tells you what kind of object you can hold on to.
yeah, let's say
The
your
methods
declared
that you
type.
can use are associated with the object you're holding on to.
So if you had an object for the declared type and then any other class after that, you could still use that class's methods, not just the
Exactly.
objects?
Right, exactly. Yep.
Oh, okay.
Yep. Again, dynamic type determines what it is you can do with that object, what method you're going to use. Now, obviously, if it doesn't have it, then it's going to go up its chain in the hierarchy. But you're holding on to a widget object. You're not holding on to a monitor object. You're using the monitor handle, but the object you're holding on to is a widget. So that's the method it's going to use, if it exists. Okay. I think this is my favorite question on the quiz today, because I think a lot of people were confused about this one. Okay?
Love to get us.
So when we
love to see
say-
students get it wrong.
Valid variable type, are we talking about static type, or are we talking about dynamic type?
Static.
Or declared type, right?
Oh, yeah.
Static or declared, it's the same thing.
Okay, thank you, yeah.
So the point is that what we can have on the left-hand side of our assignment, can we have an abstract class? Remember when we had our hierarchy, we had our animal, and we had it as abstract, and then we had our bear as inheriting from this. And then we had our interface over here, and we had our carnivore. We can declare a carnivore is equal to what? And we'll just call it C, is equal to a new bear, right? Because a carnivore, even though it's an interface, and we can't instantiate an interface, we can make our variable have an interface as its declared type. Because a bear is a carnivore, all right? That's the C here. We can do the same thing with our abstract. We can also have an animal. A is equal to a new bear. Because our picture looks like this. And my markers are done. Very well. I guess I use them too much, probably. All right. So we have animal. This is our bear, right? And then within this, we have our carnivore. Right? This one, we're going to get a handle onto it from this side. This one, we're going to get a handle onto it from this side. Okay? So that takes care of these two. And then obviously, this just makes sense, right? If you can instantiate a class, you can call a variable that, right? It'd be like, you know, bear B is equal to a new bear. Okay? And so that's why it's all of them. It's the declared type that can be all of these different things. What about on the other side? The object that we're actually going to instantiate. Can we have animal on this side? If it's an abstract class? No, we can't create a new animal. Its dynamic type cannot be animal. Because we can't create an object of type animal. We can create an object of type bear, which has animal parts to it, but we can't create anything called a new animal. What about a carnivore? Can we do that either? No. Again, we can't do that because an interface doesn't have anything to it, really. I mean, it's declared all of its methods, but there aren't any, nothing's been actually developed, right? Defined. It's declared but not defined. Yeah, Alicia.
So I get that, but I don't understand really why you would do that, unless that's the polymorphism thing where you're
It's
having
polymorphism.
the bag.
Exactly, it's
Okay.
polymorphism. So if we have a bag where we want to throw all of our carnivores, we can do that without having to have a bear bag, a wolf bag, etc. Right?
Okay.
Yeah, Andy.
Will you say again, on the left side of the equal sign, what's the words that you're using to describe that?
These are called declared are static types. On this side, this is what is known as a dynamic type. This isn't going to change. Once we declare C to be a carnivore, we can't change that part. A C has to point to a carnivore. However, on the other side, we can point it to a lot of different things. We can point it to several different bears. We can set it, we can set it equal to some wolves if we had wolves as well. Anything that has that interface implemented. Yeah.
So it's declared or static, meaning like once you set it,
Yeah.
that's what it is, right?
Yep.
It remembers it, but you can swap out this side, which is your dynamic type
Yep.
that you're pointing to, and then
As long as it has a carnivore handle on it someplace, you can use that. You can grab an object of that type.
yeah, and then the word in there. What's the wording in the question?
Instantiable.
Yep, that's the act of actually writing that statement,
Creating
right?
an object of that class.
Okay.
A class that's instantiable. Just a second, you put your arm out. I don't want you to get tired. I got you. What it means is that you can actually instantiate something in that class. Can you instantiate an interface? Can you instantiate an abstract class? No. Okay. And that's the distinction we're making. Catherine.
So whenever you see variable type, it's referring to specifically the declared or static type, not the dynamic type. That was just kind of what.
Well, you've been talking about variable. When you talk about variables, you're usually talking about static or declarative. Right? Because those are the labels we're going to give to the objects. Now, you can obviously you can set one variable equal to another, but the point is that when you declare it, you have to have a certain type associated. And that could be abstract, it can be an interface, it can be an actual class that you can instantiate or you can create an object of. All right. Hopefully that helps. All right. Because going forward, we're going to be using this stuff a lot, so any other questions before we press on exceptions? Okay. I'm gonna have to change around the groups a little bit. It looks like we're losing people. I don't feel good about that, but I don't feel bad either because we're overloaded as it is. So I'm ambivalent, okay? I wish people didn't drop, but that just happened. All right, so let's go ahead and I'll reassign groups for next time just so they're more even. So maybe I'll just flip some coins too as well. Anyway, so let's go ahead and what we're going to talk about now is we're going to talk about exceptions. All right. Before we get started, I just want to ask a couple quick questions. So, Lance, what are the two basic groupings of exceptions that we talked about? We had exceptions that are this and then exceptions that are that. Do you remember from last time? One was a runtime exception and one was just a plain old exception. But what are the difference between the two? We have an exception that inherits from the exception class or the runtime exception class. They're treated differently. Do you remember? Lance? Okay. Does everyone want to help them out? Yeah. Esther.
Aren't exceptions user handled?
Right, yes. And so what do we call those?
Are those the checked and unchecked?
Unchecked and unchecked. So which is which?
The checked ones is, unchecked, I'm just reading from my notes.
Is there- is there-
Unchecked are runtime errors, so you need to fix those.
Right.
And then the checked ones are not runtime, so that's when you use a catch block or a
Right,
call to
throws,
get
yes,
that.
and we'll look at that here in a second, okay? All right, so here's what we're doing, okay? We're talking about two basic classes of exceptions. Ones that are checked, meaning what? That we have to do either a try-catch block or we have to use a throws declaration on the method that they're called in. And we're gonna look at examples of that here in a second. The other one is unchecked, and those are runtime errors. So we'll talk more about that here in a second, but in order to kind of play around with this a little bit, let's go ahead and we're gonna create an exceptions class real quick. I'll get to these other things here in a second. But so I'm going to create a new class. I'm going to call it exceptions. And then we're just